This is the Master Brewers Podcast, brought to you by the Master Brewers Association of the Americas, a volunteer organization dedicated to continually improving the products and processes of our membership since 1887.
Let's go!
Master Brewers brings you interviews with the industry's best and brightest in brewing science, technology, and operations.
Calm down, I'm moving too fast.
This Master Brewers podcast is proudly sponsored by Hopsteiner, a global leader in the hop industry focused on quality, sustainability, and innovation in new hop varieties and hop products. Contact our brewery sales team to provide you with the hop-related tools you need to craft your next great beer. For more information, visit hopsteiner.com.
Additional support provided by
Draft Lab knows that quality and consistency are your brewery's top priorities. Draft Lab provides easy-to-use sensory analysis tools designed to bring your tasting data into action. To start your free 2-week trial today, visit draftlab.com. That's DRAUGHT lab.com.
Every brewery has quality issues. The brewing process is just too complicated for everything to be perfect all the time. I don't think there's any better indicator that a brewery is pointed in the direction of success than when you see troubleshooting like this presented transparently at a major industry conference. We see it time and time again, but only from breweries that really have their act together. Today, we'll step through troubleshooting acetaldehyde at Madtree Brewing Company.
Hello.
Hello. How's it going?
Good. How are you?
That's Becca. She's the chemist at Madtree Brewing. We'll also hear from Trent, Madtree's quality manager. Let's start with the bad news. How much beer did you have to dump?
Are we allowed to say that?
Yeah.
Yeah, so this was quite a doozy for us. It was about 500 barrels of beer over the course of about 2 months.
Ouch.
Yes.
Okay, so what was wrong with the beer? What prevented it from being released?
So we moved from a 15-barrel brew house to a 100-barrel brew house, so quite the transition for us. And as we were transitioning these beers over, we weren't having any problems except for this beer Lift, which is a Kolsch-style ale. And so we were getting indications of acetaldehyde from our sensory panel, which led to stops and then the disposal of that beer.
Okay, so you had high acetaldehyde, and you said you only saw it in one brand, right?
Yeah, so this is as we were about a year and a half ago, as we were transitioning our brands over from our old facility to our new facility. And so we weren't having any issues with our American ale yeast, and then this is a unique yeast. It's a German ale yeast. So this was the only one that we had these levels of acetaldehyde, so we figured this was, hey, what's going on with our yeast?
Okay, before we get into your troubleshooting process, let's talk about where acetaldehyde comes from. How is it formed?
So it's formed in multiple steps in the brewing process. However, the majority of it comes from anaerobic fermentation, so it's a direct precursor to ethanol.
All right. What was the first step that you took?
One of the kind of first things that we were looking at was the ASPC fishbone diagrams. That was pretty useful for us in quality meetings, looking at, okay, what are some process control things we can look at? What are some yeast related? Is there anything that we can attempt to control to deal with this issue with acetaldehyde? And it was detected in multiple batches. So we knew it wasn't just a one-off, issue. There was something going on consistently with our brewing process. So we had attempted to look at increasing wort oxygenation. However, we were still seeing acetaldehyde in final product. And one of the other issues we were having was that it didn't seem to be quite consistent of either the level that it was showing up in the beer or if it was showing up at all.
Why did you start with wort aeration? That came directly off of that fishbone, right?
Yeah, that was absolutely just directly a process control that was easy to adjust, and could maybe we needed to dial that in to deal with the problem. However, as these things normally are, it wasn't as easy as just changing one thing. So
next you tried some changes to yeast pitching. Why don't you talk a little bit about that?
This yeast we've never really had any issues with this beer before. And we do know this yeast has been hard for us in the past to do yeast counts on. Just getting a sample of it and then an accurate count for it. We've known we've had issues with that. And so we never at our old facility would do yeast counts. We would we would do about a half barrel of yeast for a 60 barrel batch of beer.
And that was just for this one strain, right? Or you were doing counts for the other beers?
Yes, counts for everything. I know we counts for everything, but just the fixed ratio for this specific yeast. Yeah.
Okay, and so when you started up the 100 barrel brew house, you were doing that still or not?
Yeah, so ironically, we started having these issues when we were attempting to do yeast counts for this beer.
Okay, all right. So when you moved to the 100 barrel brew house, that's when you said, hey, let's go ahead and count this like we do the others.
Yeah, and we were starting off using mechanical agitation to try and get a better yeast count for this specific strain. Simply just a stir plate, you mean? We have a vortex mixer. Yeah, are they called vortexers? Yeah, a vortexer. Okay. And so the next thing you tried was, hey, let's go back to that old way of doing it where we just have this, what you're referring to as sort of a fixed ratio of yeast that's pitched for this brand, right? Correct. Yeah. However, we were still seeing issues with acetaldehyde. So that didn't work? That did not work. Okay. So then after that, you even tried, I believe, a Croisen process, right? How did that work out? Yeah, so that was when we were pulling samples for forced diacetyl. We were going ahead and also checking for acetaldehyde. And if there was a fair amount of acetaldehyde, we would try and add actively fermenting wort from another batch of this beer, just as an attempt to clean up any residual acetaldehyde that was left from the fermentation process. On a scale of 1 to 10, how successful was that? It actually, so if it was really bad, I would say, wouldn't get rid of all of it, but it definitely helped lower acetaldehyde levels in the finished product. And that's something that at our old facility, when we were really crammed for tank space, trying to crank out as much beer as possible, if we had beers where we had a small issue with diacetyl, that's kind of something we've used in the past to help us clean up any chemicals we don't want in the finished beer. Sure, and so that's obviously helps a lot, but that's a Band-Aid and not addressing the root issue there. So yes. It sounds like the next thing that happened is sort of your thought process shifted to, hey, maybe this isn't actually a fermentation issue, but an oxidation problem. We didn't mention it earlier when we were talking about how acetaldehyde is formed, but ethanol can actually be oxidized back to acetaldehyde if oxygen makes its way into the finished beer, right? Yeah, after you remove the yeast, if you have oxygen in there, you can have that oxidation and reform acetaldehyde. With acetaldehyde being closely related to yeast, now our first kind of steps were looking at what was going on with the yeast, but Trent can talk about this too, later discovered this issue with the pressure relief valve. So I don't know if Trent wants to talk about that a little bit. Yeah, Trent's being bashful over there. Trent, why don't you tell us what you found out there?
Okay. So it was actually happenstance. I overheard one of our brewers talking about how he was running a CIP cycle on one of our tanks, and I forget if he was running caustic or acid, but he had noticed that it was coming out of the PRV and down the side of the tank. And it didn't really hit me at that point, but just randomly later when I was, trying to figure out what was wrong with the lift, it clicked that PRV was like leaking. And so I went back and looked at all our data and realized that like the bulk of the issues we had were out of that tank. So we immediately like replaced it or reseated it. It may have just been like a seating issue or something. I forget the actual issue with the PRV, but it was addressed, and we did have some good luck after that, but didn't have all good luck after that.
So that did reduce the acetaldehyde levels, but
yeah, well, so we just had a few good batches, and that was the most frustrating thing with this issue. Was like we would think that we fixed it, but because the issue is ultimately our yeast counts, sometimes we would get good pitches or have good pitch rates, and those were the good batches. And if we had done something the batch prior and we thought we had fixed it, when in fact it was just kind of a false impression of the fixing the problem.
Coming up.
And the phosphoric acid treatment is beautifully normal compared to the original coal schist, and even compared to the vortex and the hydrochloric acid treatment.
I'm John Bryce, and you're listening to the Master Brewers Podcast from the Master Brewers Association of the Americas.
This Master Brewers Podcast is proudly sponsored by Barna Mechanical, a full-service design-build firm specializing in turnkey process and utility systems for the brewing industry. We partner with some of the best craft brewers in the U.S. to ensure the great beer they brew is what their customers get in every glass, bottle, can, or keg. You know beer. We know breweries.
Additional support provided by
ABS Commercial is a full-service brewery and parts outfitter. From our Raleigh headquarters to our Denver office, we proudly offer brewhouses and fermenters from 3 barrels and up, yeast brinks, boilers, kegs, chillers, tri-clamp, and other stainless parts, all with the quickest delivery and lead times in the industry. Learn more at abs-commercial.com or call 877-BREW-ABS. ABS Commercial. We are brewers.
Here's what's coming up on the Master Brewers calendar. The District Michigan Quarterly Technical Meeting is October 18th at Coonan Brewing in Clinton Township. District St. Louis meets at Charlottesville Brewery October 18th. Don't miss the Canned Seaming webinar October 19th. The District Philly Technical Weekend is October 19th and 20th. District Southeast Fall Meeting and Technical Session is also happening the 19th and 20th at Tank Brewing in Miami. The Master Brewers 2-week Brewing and Malting Science course begins in Madison October 21st. District Rocky Mountain meets at Miller Coors in Golden, Colorado October 25th. There's plenty of other meetings in November as well, so be sure to check out the full calendar of events at mbaa.com for more details or to find a district meeting near you. Now back to the show. The poster you guys presented at the Brewing Summit has a few histograms that nicely summarize the remainder of your troubleshooting. Tell us about the rest of that problem-solving process in a way that the poster can't. How did the aha moment go down?
The aha moment was just doing, it was another yeast count on the lift and being super paranoid about it by this point. And I think I had drawn up, a sample from the dilution slurry, and it was a ridiculously high count. That didn't even make any sense. So I just did a duplicate count, and then this time it was super low. And then at that point, I was just inspecting the flask of the dilution sample, and I started seeing these little flakes kind of settle at the bottom. And when I went to pull those out directly with the pipette and put it under the microscope, it was just big clumps of yeast. And then that's when the light bulb went off.
All right. So what happened next?
Well, from there on, I was looking at a lot of stuff online on how to declump yeast or get them to separate. And I actually think I'd come across some poster. I don't know if it was ASPC or MBAA, but they had done some validation with an automated cell counter that used some different techniques. So then I borrowed some of their numbers to start with, and we tried the 3 different methods and compared them using the histogram. So we had a lot of data from, counting our American ale yeast, which we had never had an issue with. And we had it down to, well, if you're familiar with the hemocytometer, it's a 5x5 grid, and you take, you count 5 of the squares in the grid. And so we had all that data going back for the American ale strain. And so we collected all that and made a histogram out of it, and it was normally distributed. And so then I did the same thing for the Kolsch yeast that we had done so far, and half of it was normally distributed, but then of course there were these bars on that end that were super low and super high, so it was not normally distributed overall. And so we used those 2 as kind of like a negative and positive control, or a target and what we don't want, and tried the different methods, the mechanical, hydrochloric acid and phosphoric acid. And the phosphoric acid treatment is beautifully normal compared to the original Kolsch yeast, and even compared to the Vortex and the hydrochloric acid treatment.
All right, why don't you expand on those methods a little bit more? Tell us a little bit more about the results for them.
Right. So we had our controls. We had our American ale control, which is what we were shooting for, and our normal, not doing anything, counting the Kolsch yeast like the American ale yeast control. And for mechanical, we just had the Vortexer that we did 30 to 60 seconds of mechanical agitation. And went from there and treated it like a normal count after that. The 2 acid treatments did not get vortexed. They were only treated with their respective acid treatments. The hydrochloric acid looks like a 10 millimolar hydrochloric acid solution, and the phosphoric acid was 2% phosphoric acid solution. And I think we did like 5 replicates of each technique, and then I think we also counted all 25 squares in the grid. We didn't just do like a normal cell count. We were trying to get as much data as possible, and put all that data together. And we also, so for each 25 square grid, we used the mean from that data and subtracted the mean from all the individual numbers, and so that kind of normalized it across multiple the replicates. So each time we filled up the hemocytometer, we'd have a different mean, and we'd subtract the mean from those raw results, and then you could compare them across different hemocytometer samples or replicates. And so that's what made the final histograms that you see on the poster center around 0, and also kind of normalizes so you can see the distribution that actually takes place. And so from those results, we made the histograms, and it was more of a visual inspection from there. There wasn't any like hardcore statistical test or anything. It was more just like eyeballing it, like, oh, well, I think we figured out the problem here. Our SOP for our lift yeast count now is 80 mils of water, 20 mils of 10% phosphoric acid solution, and then our yeast slurry and methylene blue. And it's been great ever since.
We know from Greg Casey's fishbone diagram that increasing pitch rates or decreasing yeast growth causes higher acetaldehyde levels in beer. So you were simply over pitching, right?
Sometimes, and sometimes massively under pitching. I mean, we were I'm sure that sometimes we screwed up both ways, depending on how the sample was drawn. If you got like one of those flakes from the bottom of the flask, you're going to have a higher than representative count, and vice versa. If you were pulling from a nearer to the top of the dilution, you would probably get a lower than representative count of the yeast.
Makes sense. Do you want to talk about the role serial repitching may have played?
Yeah, so I think this also was led to frustration for trying to figure out what the cause of this problem was. So yeah, serial repitching with stressed yeast can be a problem, and any issues you were having with that prior generation can carry over to the next beer you pitch it in. And so we were going cone to cone for all of these beers, since we were just starting up at this facility and there were no other beers that used this yeast. So we had a batch that was good, and we had no acetaldehyde issues. But then if we pitched that beer incorrectly to the next batch, then when we reused that again, we were still having acetaldehyde issues. It was really awesome to talk to people at the Brewing Summit, who either had this issue or, just being open and communicating quality issues, because, you're not the only one out there dealing with those. So I think the more open we are about it, the further we all grow.
Does your brewery have a great troubleshooting story to share on the Master Brewers Podcast? Use the contact form at masterbrewerspodcast.com to let us know. Like Becca said, the more open we are, the further we all grow. If you're not familiar with the fishbone diagrams Madtree used to troubleshoot their acetaldehyde problem, do yourself a favor and go to mbaa.com/store. Type fishbone into the search bar, then get a copy of Brewing Chemistry and Technology, which includes 120 cause and effect fishbones by Greg Casey.
One day, like everyone else did.
They are a godsend when there's a problem, and they're a great starting point if you're trying to just learn the overall high-level relationships and what contributes. And there's good citations on there too, so you can find papers from there. I think they're super valuable, especially when you're trying to troubleshoot something.
That I should have mentioned that, but I did. My fist full of courage, my heart full of rage. Well, I can't get stuck, I can't be losing too much, and then I'm heading out to any other place.